I'm going to give a brief overview of some of the things that we've been doing. This is going to come from an applicator perspective and tell you a little bit about our research. But my name's John Fulton. I'm with Ohio State, and one of our focuses, or my focuses, has really been nutrient application equipment here the last few years. So, anyways, for those of you that have not been in here, we've been using Slido. It's an app to ask some questions. So we might ask some questions once we get everyone calmed down here. But anyways, I'm going to jump in, and I'm going to kind of blend into what Trey was talking about a little bit. And in my perspective, today, in terms of implements, machinery, and technology, we've got a pretty wide nutrient toolbox to pick from. The question is what makes return on investment? We've heard a little bit about those comments today. But I would also advocate that as you consider some of these technologies and implements and new machines that have come onto the market and available, I think you really got to, and what Trey was trying to highlight, what works best within your farm operation. That's very important. And I will tell you, from my perspective, as I travel around, I see misuse of some of the implements that are out there that are available for placing nutrients or incorporating nutrients. Okay, and so anyways, I think the toolbox is pretty wide, but I think one of my take-homes today is make sure whether you're consulting and giving growers recommendations or you're a grower trying to evaluate that you pick the right tool, right implement for your system. Okay, and so anyways, I think there's a lot of opportunities. I'll talk a little bit about that in the morning, about some of the research and the data we've got from the benefits of going to variable rate or spatially managing inputs. But I think this is a clear image of fields and the conditions that we work in here in Ohio. And I want to allude to some of the comments that when we start benchmarking and start aggregating some of our information with some of the I-states, specifically Illinois and Iowa, they don't see as much value or opportunity as what we see in Ohio, okay, because of the conditions, the field variability, whether that's both terrain and soil. In this case, what you see is basically organic matter variation, texture variation in that field. And we know, and you're going to see some pictures in a bit, that our ability to go out there and place P and K, we can do that effectively on a variable rate strategy and see benefits, both agronomically, but also environmentally. Again, I want to leave a lot of those comments in the morning. So that's kind of our situation. There's a lot of things that we focus on in terms of what we do research. You've seen a little bit of that today. I'm going to jump back and do something I enjoy doing, and we've been spending a lot of research on, and that's machine performance. And I'm going to talk specifically to a few implements out there and what we're finding, both as implement opportunities, but we're also seeing there's some limitations that we're starting to uncover with some of this stuff. So we think execution matters. This is a field where, in this case, nitrogen was not applied uniformly out there. And again, we heard John talk about imagery, but if it wasn't for the picture, we wouldn't know this existed. But this is a case, and I'm going to get into a more concrete case example that we got into in the next one, but it does matter. And so that's non-uniform application. In this case, we talked about variability, field variability in the first slide, but we've got a tremendous amount of machine and operator variability adding into that equation too as we go out and we evaluate. And I would contend some of Jeremy's comments earlier about how do I sample and then I see some variation when I go to a densified sampling. There's both the in-field variability, but there's a lot of things I think that we do as an operator or a machine that adds to that as well. So this is a case, and I'm going to get into this a little bit, but this is corn, and this is I think it was an early July image that came in, and so we worked with a company that did the custom application on this field, but basically what you see is 90-foot strips or 90-foot streaks out through that field. Okay? And I would tell you that what happened here is two things. It's not necessarily the machine's fault, but it was the operator as well not improperly setting up the machine to deliver product uniformly out here in this cornfield. So this was a kind of a side dress, over the top side dress in corn. And this is kind of the result that came out of that. So first of all, what happened here is that the company, unknown, but a grower said, I want this type of blend. So they're calling in a specific blend, and I'm going to apply this with one applicator across the field. And I want basically primarily to add more nitrogen to the blend. So we're adding totally two different products into the bin that shouldn't be blended. Okay? And so the result of that is what you're seeing is basically two things. Segregation, okay, of the product. In this case, the primary nitrogen component of the product is separating from the primary P product that was put in this as well. And so the result is you see the result from the nitrogen very clearly. That was evident in the corn, but underneath that, and we've got data to show you that basically it would be an opposite picture for the P. Wherever you see green in this picture, you'd see very low amounts of P applied. Where you see kind of yellow, you get high P applied in this particular case. Does that make sense? So again, incorrectly blending. And again, this is a farmer saying, I want this type of blend formula, but not thinking about really what this case would, what I would allude to is advocating for two different separate applications of the products. But at the same time, what happened was when we talk about setup, and I'm going to show you a little bit about this, is guess what the operator never did in the cap? He never adjusted the product density. Okay. So he never adjusted the product density in the display, which is critical to getting it properly metered out the back. You got to know the density because we've got a conveyor in this case. And that conveyor's over time, it's moving at an RPM. And we got to convert that to pounds per second or ultimately to a pounds per acre with our speed. And in this case, that pounds per product was incorrect. So we're actually over applying at the end of the day. So again, I'm just giving you some context here that there's these type of things that we got to get the base things right. I would argue here today if we see this type, this is not even a variable rate application, this is a fixed application where we had two issues that cropped up to cause this to happen. So here's the result. We went out to the field, we put the product in, and you see basically the pattern. If you can catch in there, you get a lot of the P particles out here. You can see that. And if you notice in the middle, you get a lot of the lighter particles, in this case, the nitrogen component in the center and not so much out to the side. Okay? So again, working with the operator, we can correct this. Okay? We can correct this and do a much better job and a uniform application. But again, we didn't recognize this on the front side, what might result in this. But we had never known this, just to highlight, we would have never known this if this image would have never came in. This came in, the operator, the farmer, everyone came together. We're going to figure this out. Within a few days and paying testing, we had the problem fixed and we're going on and everyone's happy kind of scenario. Okay? How did it turn out? I kind of left the discussion at that, but I'm presuming some people picked up the cost that the farmer didn't have to pay. So I can't speak to that though, how it turned out exactly. But there's pretty good evidence at the end of the day we understood what happened. So this is what it can look like. And this is basically some work that's been done, but that's an as-applied map. And again, if we're not paying attention, okay, especially on the front edge of getting things set up and calibrated, we basically see non-uniform delivery. Okay, and we know some of these products are hard to maintain uniformity at times, but this is just an as-applied map with basically the blues being very high and the reds or yellows being low application of that product. You would want that whole field to look green in this case. Okay, so blue is actually a little bit of an over application. But again, we've got these irregular shaped fields. So my point in this is fixed race application can be very difficult given some of the scenarios we're putting some of these machines into, and that's kind of been alluded to over the day. We're putting big machines, trying to throw 90 feet or trying to apply at 60 feet or 40 in some cases. But it gets pretty tough. Make sure, and my only point here is if you're not getting the basics right, if you're not getting this green right, how can we jump to do variable rate and make it a positive return on investment for you guys as growers or consultants that are helping them generate those recs, okay? So we don't know the percentage of time this happens, but what I'll tell you, and Andrew, is we saw this a lot in imagery a couple years ago when we were running an imagery project, that it happens more frequently than I think we might guess. So some challenges, and I'm going to go through this. The materials affect two things here, folks, and I put the key attributes of materials that affects. Number one, the metering. Okay, so it doesn't matter the metering type device. It's a spreader, it's a dry fertilizer applicators like what Trey was talking about, but as those material properties change, so does the metering characteristics. Okay, so moisture, and I put moisture up there because that's probably an area I would put that in the line category. Okay, but when I come to dry fertilizers, number one, product density will affect anything more than number one. Particle size is number two, so I'm going to give you an example. I can take a DAP particle or a MAP particle. There's two things. Number one, it's going to be bigger than typically a potash or like a urea or something like that that's going to be smaller. And I can throw that further than I can those other two products. So particle size drives how spreading of materials primarily. Particle density is important. I put that up there, but it's particle size that drives the ability to uniformly spread. So what that tells you is there has to be calibration for every product. If the product density is different, particle size or particle density, and you want to come back and show you some data here in a little bit. If I'm going to blend products, that there's two things that need to be common between those two products. Does everyone know that? Particle size is number one, and you hope that the product density and particle density, but product density are very similar. Those are the two key up here things. If I want to blend products, I need to be looking at a sheet for those two characteristics if I want to try and blend them up. If they are very dissimilar, I would not be blending them, regardless of how I'm metering them. Because most of the time I want to meter them and blow them out pneumatically somehow. We see some separation there as well. The controller, we must maintain RX rate. I'm going to show you some data that's very encouraging today for the new modern machines. And then it has to be accommodating for the ground speed changes. We want to do that fast, right? We want it to be able to account for changes in rate because of prescription. But as an operator, as I speed up, slow down, it also has to account for that as well, right? And we want that to happen fast. And I'm going to tell you today, if you got a newer machine and it's got a PWM valve on it, most likely it's doing it almost instantly. If you got an older machine, there's a good chance it might take up to 3 seconds before it actually changes the rate. Okay, and if I'm traveling 15 miles an hour, that's a pretty significant thing. And then some distribution. I'm going to talk about that in a little bit. The rate of material that's being metered changes how it's distributed. Okay. So I just wanted to highlight that we put this out in as a result of understanding that some of the operators are not changing their product density in the display. I'll show you that. But we put this this is online. You can let physical properties of granular fertilizers and impacted spreading, and it goes into much more detail than what I ever talked about here today. But if you're very interested in this and want to learn more, this details physical properties and how it influences or can influence both metering and distribution across machines. Okay, I highlighted some things. Here's urea, okay, 46,000, and all I'm saying is the product density is 45 to 51. If I jump down here, MAP, which is very common, it's going to be somewhere between 56 to 66. I'm not saying that it's absolute. You should always check it, but that kind of gives you a range that if my controller, in this case, okay, doesn't have that, then that gives a range that it should be out there. This is the other issue we get in there, source. I'm sure for those that work in the retail sector can describe this, but what I will tell you is these are basically potash from 3 different sources for the most part, but you see differences, and I will tell you that after we did our research, I needed a calibration, different calibrations for each one of those sources if I'm into the accuracy piece of getting it uniformly applied. And I can get each one of those uniformly applied on the applicators we've been working with, but it takes calibration of each. If I'm truly into precision and doing variable rate, I need a separate calibration, though each one of them is KCL. Okay? So we've learned that. Again, and so this is what I'm talking about. This is a menu product density. In this case, I can tell you we're probably doing DAP at 70, or KCl, excuse me, potash at 70. I put that density number in, and that has to be changed for some degree as we change loads over the day. I would encourage checking that somehow. So anyways, so that's a portion about product. We'll talk a little bit about uniformity, just what we've done. This is a recent, I did on a pan test. Again, my point here is when I'm given a product and I'm given some of the newer machines that apply these products, high clearance typically is what we're running for these, that I can do a really good job to get a single pass pattern out of those machines. Now that takes some time because of it's tedious to do the pan test, but what I'll tell you is I get two things out of this. I get good uniformity, but when I look at the metering of product, in this case we were applying around 300 pounds per acre, okay? I have to look what we were doing DAP on this one on a self-propelled high clearance. Look at where I'm actually metering within a percent. I can get the conveyor system for that product within 1% or 2%. I typically say we should be able to get under 2.5% on these type of machines today, okay? But the big thing is I can get it to be uniform. That doesn't say a very similar machine. Here's a distribution pattern that we saw what was called a calibrated machine, okay? So this is very common. We'll go out, we'll help or be asked to help, and you get something like that. I would call that where you're going to be light in the center. You're going to be kind of heavier out on the outside, and this requires some attention, okay? Doing a spread pattern test. Again, I know that's a very tedious, and I would encourage people to be doing that kind of annually on these machines because it's just the nature, or at least that's our been experience. And the other thing is to document the final calibrated settings. What's discouraging to me is when we show up and I want to know what the settings were last year, not what's in the truck right now, but what was it last year for that product, and the operator can't reel those off to get it set back up to that. Okay, so document settings, because those are very important, because in our research, if we document that and we come back to the same machine, we find trends. We're always adjusting things, but we find trends about getting it in and accurately metering and getting the uniformity as good as we can. Okay? Rate response. This is what it used to look like. Okay? This is some research we did, but that's a rate change line. Okay? And the applicator's coming from here up, and it's supposed to be changing somewhat instantly. So I'm doing a grid or a polygon. When I hit that line, there's a time to make the rate change. This is what it used to look like. And it would take us, and I know this is the meters, but in some cases we had trucks and applicators, depending on ground speed, it might be up to 100 feet before you actually see a rate change made. Today, and this is well, I'll get to that in a second, this is what we'd see. We'd take a while, and it took the ball valves and the proportional valves some time to make that change, okay? And the other thing is, for most of you that are either giving suggestions to the operators, that there is a tuning to these valves. Okay, if you've run sprayers, for example, you understand that there's a rate response. We call it the valve control number that you can mess with to help get it tuned, and that becomes an important ingredient in order to get it tuned right, to get the response. But you see two different valve control numbers, same applicator, giving you two different responses on variable rate or rate changes in that case. But the tuning becomes very important. This is what we see today. And again, this is directly off a commercial applicator. And basically, we're kind of doing some steps. We replicated this. You just see in one replication, we stepped down and then did a step back up. But you see that rate change line mirroring, no offset, no latency necessarily. But if I'm making a rate change, they're opening and closing and getting to that rate very quickly today. So that does not preclude what Trey talked about. This is just upstream. If I've got to convey that out a hose or something, or if I'm on a spreader, there is another change, a second, whatever that is, before it actually gets to the point where it either is injected in the ground or gets applied to the surface. But today, I don't have to worry about the latency of the valves, typically. They are very quick, and that's encouraging for us when we think about all the application that's out there, and we're doing it on variable rate. So that's a positive. And again, my point here is we've looked at how to tune these, and the big thing is you need to tune the valves. We can talk to you about some suggestions we've had over this, but tuning some of these valves, but it's a lot easier today than what it used to be at least 5-10 years ago when we were doing some of this. So one of the other things that's growing, and Trey kind of pointed to too, is this fact. And I would say most of us that are doing any kind of soil sampling, whether it's zone or grid, are coming up with maps like this. And so, but we're also seeing the industry at a point, it does come at a little bit of an elevated cost over just a standard one bin type thing, but we're seeing dual product delivery or multi-product delivery much more common and an option out there for folks to have access to. Okay, so I can put two maps in. Here's a map and then the potash. I can put both those maps in one machine, a tractor or spreader, and go out there and execute that. Okay, and I would say that's very encouraging for me, because up until this point, I think we've just kind of been coarse knobbing things if we're doing a blend, okay, from a variable rate perspective. But we can meter two, and this is what Trey was talking about. Again, I can put one product, and in this case, potassium in the front as an example, MAP in the back or DAP in the back, and I can independently meter as I go across and turn off, or I can meet whatever the expected rate or the established rate is there on the rec for these particular things. The nice thing that Trey didn't mention is for some of the newer technology, not only can I do variable rate, but the technology of automatic shutting things on and off, the automatic section control is already embedded in most of these equipment today. So that's not a second purchase I need to make, but something that you can do that just kind of comes embedded in the machines as well. Here's a dual bin spreader. In this case, you can see DAP in the front, potash in the back. Again, I would advocate that's a good way to execute on prescriptions today. And I think our retail sector has responded to that, and there are a lot more options out there. There's still a lot of one single bin spreaders out there, but in this case, you see that we're having two there that we can do. And there's actually more that we can add. You guys probably know that. We can get up to 6 in some cases. So when you add micros and such. But what does this mean? And so here's one of our research things that we've just come up with. So we got back to, remember my corn example in the front where we're adding two products and we had segregation across the field and we got streaking as a result of that. Okay, both on N and P. What you see here, and I'll explain this is the pattern, okay? The blue or the green is the DAP being spread only as DAP at the rate specified in the blend, okay? So we have DAP only at about 200 pounds. And then what you see is basically the DAP at 200 pounds in both an independently metered system, like what you see here. And we also did it where we blended the potash and DAP together in the appropriate ratio. But what you see is the same DAP rate in all three scenarios. Does that make sense? But the point in this is what we found is when I turn the potash off, what happens to my DAP pattern? So if I'm executing those two prescriptions out there, okay, and the point in this is I change the metering of product on some of these applicators, the pattern in some cases, depending on how they're generating the pattern, is going to change as well. That's what this tells us. And so in this case, if I'm going across the field and I calibrated, but if I turn the potash off, all of a sudden the DAP generates a whole different pattern than what we had prior to it being on or in a blend in this case. So this is something that we've got several people maybe interested in kind of figuring out, because what this says is our settings are going to have to change on the go to accommodate this type of scenarios. So we look forward to possibly having some things in the future to accommodate when these type of scenarios come up out in the field. Of course, we talked about this. Some of this information I just showed is in e-fields. And I just kind of summarizing just a few things I went through. What we're working on is, technology setup and the tuning is very important today. And I would advise you, if you don't know or if you need some help, let us know. Calibration is critical. And I say that in a way, too, that calibration is becoming more important by product. Okay, it's almost like a grain yield monitor. I need one for corn, I need one for beans, but as the products change, you need it. And the other thing, and I'll talk a little bit more about this in the morning, from a true opportunity and return on investment for growers, the opportunities around variable rate fertilizer take time. And probably there's several of you who'd raise your hands and say, yes, that's true. But if you haven't done this and are working yourself into it, the true opportunities both agronomically, economically, and ultimately environmentally, what we're getting challenged with, it takes some time. Okay, so with that, we'll take any, if there's any quick questions or comments to what we have before we adjourn for the day. Oh, it's time to go. Yes, sir.
You have the slide on rate response. I was wondering, does topography play a role in the rate response that you have? Landscape?
I would say it depends on what you're talking about, but typically your question is, does topography influence rate response? Typically it's not rate response, it's uniformity that's going to impact more on most applicators. Okay? So if you get to rolling the machine, you'll definitely get some variation in metering or distribution a lot of times across the machine. Yes, sir.
Which two of those three factors do you say have to be the same?
So if I'm going to take and I'm going to blend a product, particle size is number one. I need the particle size to be as close or near. And typically we use the D50 value from like a GISI or uniformity test. And then the second thing is particle density. That publication actually puts them in order. We put them in order. So, yes, sir.
Where do you get that publication on the Ohio State?
Yeah, so we got the Ohio State PrecisionAgUp.com. If you actually go there, you'll see a button or an icon that says, I think, application technology. If you hit that, there's a publication that talks about the physical properties and spreading. So there's some other publications as well alluding to this.
Got any information on there on air, air systems, fluid delivery systems?
So your question is, do we have anything up there on air boom systems? Not directly to air boom systems, but I got some information and data if you want to see any of it. You'd have to email me though. But we haven't incorporated it into kind of I actually do have some publications I could pass along, but they're research publications. So. All right. If there's no other questions, we appreciate you all being here today. We'll adjourn and we'll get started back in the morning. Thank you.